So let's say we have the two matrices A and B given here, where A is a one row, three column, so 1 by 3 matrix, 2, 3, 4, and B is a 3 row, one column, 3 by 1 matrix, 3, 4, 5, where we want to compute AB and BA. Now, I'll say with these, we get to do this because looking at AB and BA, we've got a 1 by 3 and a 3 by 1. What we need essentially is for the middle to match. So if we do A times B, we have 3's in the middle. And then for the second case, B times A, we have 1's in the middle. In either situation, we get what we need and we can handle this mathematically. But mathematically, it's not the most interesting thing with these examples. There's something that happens in each that's kind of nice, but we can do a little bit better as far as understanding what's going on here. So for the sake of that, let's just keep this math in the back of our mind for a second and instead start by framing this with a bit of a real-world application, where let's say that you need to make a salad. I'll say they got this example from making cocktails, but somehow I doubt that the administration would be happy with me telling many of you who are probably minors about making cocktails. So I guess you'll have to Mad Lib your way through this example instead. But let's say you're making a salad, and for the salad, you need to get basic stuff. Let's say you need tomatoes and you want 2 of them where your 2 tomatoes are $3 each. So if you want to find out how much the tomatoes are going to cost you, it's 2 tomatoes times $3, right? And then let's say you also need some peppers. Peppers in the salad, I guess, a little bit of spice in there. And let's say you need 3 of those, and they're $4 each. Okay, and it's a salad. You're going to need some lettuce in there. You're going to need some leafy greens. And let's say you need 4 heads of lettuce, and those are $5 each. And let's pretend that this is some weird, out-of-touch, and very expensive organic store, so these prices make some sense for produce.
I mean, it's 1 banana, Michael. What could it cost? $10?
You've never actually set foot in a supermarket, have you?
But if you wanted to get this total cost, you take all of these, each of these products, where you're multiplying the number of things you want by the cost per thing to get that in total. Your unreasonably expensive salad would run $38. And actually, when we're going to do the matrix multiplication, which we'll see right here, it works out in much the same way if we're going to do A times B. So for A times B, we're going to take the 1 by 3, 2, 3, 4, and multiply it by the 3 by 1, 3, 4, 5. And we're going to go term by term, matching like terms. 2 times 3 plus 3 times 4 plus 4 times 5 to get a lonely 1 by 1 matrix, 38. So we can think of this as answering the question with the multiplication of these two matrices. How much does it cost in total? Or how much does it weigh in total, or whatever you have? What is the total amount for a combination where you have 3 amounts of things with 3 separate weights associated to them? In this case, I looked at the cost for a salad with 3 ingredients and 3 prices. But hopefully seeing that sort of combination here, seeing that sort of arrangement helps clarify a little bit what's going on with the multiplication here, how that column addition and multiplication thing forms a matrix. With that in mind, let's think about going the other direction. So here, we're looking at multiplying b times a. So we're thinking about the salads. We're looking at multiplying the costs by potential numbers. So when we're taking, in this case, I'm not going to write it down because it's a little more complicated. It doesn't have that same nice single line relationship. It's also a little longer anyway. Multiplying that 1 column 3 row, 3, 4, 5, by the 1 row 3 column 2, 3, 4, what we'll end up with, because we've got the 1s in the middle and the 3s on the outside, is a 3 by 3 matrix instead. So in that first row, which is kind of weird to think about, we're multiplying the first row by each of the 3 columns. We're multiplying 3 by each of 2, 3, and 4 separately. And then for the second row, we multiply 4 by each of 2, 3, and 4. And then 5 by each of 2, 3, and 4. So when we take all of those pieces and make our big 9 option, our 3 by 3 matrix as a result, we'll get 6, 9, 12, 8, 12, 16, and 10, 15, 20 as the elements of the matrix of this product. And this helps us in 2 ways, I think. For one, it's actually 3 ways. For one, it's just good practice to look at this. And yeah, I did that one a little bit quicker than you guys may have needed. It might need a little bit more time for it to sink in your head. It's perfectly fine. This is a complicated process. So look over it a bit on your own. But 2, mathematically, it should now be very abundantly clear that, at least in this case, AB and B times A are very different. Now, you can't prove something with one example, but this example should illustrate the thought that you can get to very different places. And then also, to help understand that idea, that AB doesn't need to equal BA, we should also think about the questions that these multiplications are answering. Because in the first case, the question we answered was, how much does it cost total for our salad? Whereas in the second case, if we think about it, what these 3 rows tell us is how much it would cost to get different quantities of each one thing. Like that if we're thinking about 4 being the obnoxious cost of a pepper, the second row in our product tells us that it would cost $8 to get 2 of them, 12 to get 3, or 16 to get 4. And it's the same idea for the first and third rows as well. So one answer to question, how much is it total, and the other answer to question, how much would 9 possible options cost? And those are very different things to be looking at. So it would again be reasonable that the product doesn't commute, that AB does not equal BA, both for the fact that mathematically you get something strange and also for the fact that you can think of these products as trying to do different things. But anyway, next thing we're going to look at is another example here where hopefully with this stuff in mind, we've got a bit of a clearer picture for how it's going to go.